morning everyone. This is Vijayasri, working as an assistant professor, Department of CSIT, MLR Institute of Technology. In today's session, we'll discuss about pointers in C, overview of the session, pointer arithmetic, pointer to array. So before this, we'll see what is a pointer. In previous session, we have discussed about what is a pointer and types of pointer. What is a pointer? Pointer variable is used to store address of another variable. So pointer is a variable which is used to store address of another variable. How to declare a pointer? Declaration of a pointer is data type, dereference operator, and a pointer name. So here PTR is the pointer name. Suppose here I declared one more variable called int a. So pointer variable which is used to store address of another variable of same type. So about this we discussed in the previous session, and now pointer arithmetic operation in C. So already we know that pointer stores address of a variable. Address of a variable is an unsigned integer value. That means it takes only the positive values like 1, 2, 3. In that way, it will take a positive value, that is numerical value. So we can perform arithmetic operations on pointer values. But when we perform arithmetic operation on pointer variable, the result depends on amount of memory required by the variable. So how much memory is required for that variable will perform arithmetic operation on that. In C programming language, we can perform the following arithmetic operations on pointers, that is addition, subtraction, increment, decrement, and comparison. So the arithmetic operations we can perform on pointers are addition, subtraction, increment, decrement, and comparison. So coming to addition operation on pointer. In C programming language, the addition operation on pointer variable is calculated using the following formula. How to perform addition operation on pointer? By using this formula, that is address at a pointer, number to be added, this is unsigned integer, then bytes of memory required by data type. Let us suppose consider an example, int a comma b. These are the two variables, and take two more pointer variables called ptr1 and ptr2. These two are the pointer variables. So pointer variable stores address of another variable. So suppose ptr1 stores address of a and ptr2 stores address of b. Now consider one more pointer variable called ptr3. So here I am taking one more variable called ptr3. So ptr3 is equal to ptr1 plus ptr2. Is this possible? So here ptr1 holds address of a, ptr2 holds address of b. Can we do addition operation on two pointer variables? No, we cannot. We cannot perform addition operation on two pointer variables. Two addresses cannot be added. What can we do? We can add an integer constant to the pointer. That means ptr3 is equal to, what can we do? ptr1 plus 2. We can add an integer constant to the pointer, but we cannot add two pointer variables. This is not allowed in C program. Then, so here how to perform that addition operation? Address at pointer, number to be added, and bytes of memory required. So address at ptr1, what it is doing? It is holding address of a. Suppose here we have a. The address of this is, let it be 1000. So what is ptr1 holding? ptr1 is holding address of a, that is 1000. Plus number to be added. Here number is 2. Then bytes of memory required. Here ptr1 is a type of integer. Integer memory size. Integer occupies the size of a memory is 4 bytes. 4 bytes of memory is occupied by the integer data type. So into bytes of memory required by data type. Here the data type is integer. It requires 4 bytes of memory, suppose. So 1000 plus 8, 1008. So PTR3 value is 1008. By like this we can perform addition operation. So now coming to the example. So in this example, we have 3 types of variables. Those are A is of type integer, B is of type float, and C is of type double. Then we have 3 pointer variables. Those are P, Q, R. So as we all know that pointer holds address of another variable. Pointer is a variable which stores address of another variable. So here P is an integer type in which it holds address of A. Then Q is a float type which holds a float variable, that is B, address of B. Then R is a double data type. Then R is equal to address of C, where C is also double. Then P is equal to P plus 1. So Q is equal to Q plus 2. Then R is equal to R plus 2. These are the integer constant which we can add to the address. So suppose here A is a variable. Suppose the address of this variable is 1000. Then B is a float type of variable. This address is 2000. I am assuming these addresses. Then C is a double, which the address of this is 3000. Now P is equal to address of A. So what P can hold? P holds the address of A. Here address of A is 1000. So that is 1000 plus 1. 1 is a number to be added. Then this is of type integer. Integer occupies 4 bytes of memory. So 1 into 4. So this is 1004. Now Q is a float data type. So Q holds address of B. Here I consider the address of B is 2000. 2000 plus 2 is a number to be added. Float occupies 4 bytes of memory. So it is 2008. Then R is a double data type. So R holds the address of C, where address of C here I consider that is 3000. 3000 plus 2, where double occupies 8 bytes of memory. So 3008. Where we all know that address here, the address is 1000, 2000. I am assuming for simplicity purpose because address is in the form of hexadecimal. As you can see this, address of P and address of Q and address of R. So in the same way, we can also perform subtraction operation on pointers. So subtraction operation, how can we perform? So the formula to do subtraction operation is the same address at pointer minus number to be into bytes of memory required by data type. Bytes of memory required for that data type. Suppose here I consider P is equal to P minus 1. So where 1 is a number to be added, what does P do? P holds the address of A. So in previous example, I consider address of A is 1000. So P is equal to, so let us suppose the address of A here is 1020 minus 1, where it is an integer type which holds the size of integer is 4 bytes of memory. So 1020 minus 4, so it is 1016. In this way, we can perform subtraction operation on pointers like addition. Then next is pointer increment and pointer decrement. We can do an increment operation on a pointer and decrement operation, where we all know that increment means it adds 1 and decrement means it subtracts 1. So So here we have an example. Here I consider A is of type integer. Then pointer variable is also type integer, where we all know that pointer holds address of another variable. Here P is a pointer which holds address of A. Then printf. Initially I am printing this pointer. So let us consider A as a variable and this is a memory location of that. Then the address of this is suppose 2020 is the address given to that variable. Then P is address of A, where this is the address. So the value of pointer is 2020. Then now I am printing printf P. So it prints. Then after that what I am doing is P++. That means I am incrementing that pointer value. So P++ is nothing but P plus 1. So that is where P value is 2020 plus 1, where it is an integer type. Here I consider the pointer type is integer. So integer occupies 4 bytes of memory. So it is 2020. We can see this here. So here P value, let us consider the last two digits, it is 72. Now after increment, that means P plus 1. So now it becomes 76. Now P minus means it decrements by 1. P minus is nothing but a P minus 1. Decrement operator, where P value is 2024 minus, I am decrementing it by 1. So number to be added into occupies 4 bytes of memory. So again it is 20. As you can see the output in the example. So these are the operations which we can perform on pointers. So next is pointer to array. So pointers to array in C. In C programming language, when we declare an array, the compiler allocates the required amount of memory and also creates a constant pointer with array name and stores the base address of the pointer in it. What array do? Array stores the base address. The base address is nothing but a first element address of an array, first element of an array. Let us consider an array. So suppose this is an array. Array name is A. We know that array index starts from 0, 0, 1, 2, 3, 4 and ends with n minus 1. So suppose here I am storing the data items like 10, 15, 20, 25 and 30. So the address given to the first index is, suppose it is 1000. Then let us consider 2 bytes the integer occupies. Integer data type occupies either 2 bytes and 4 bytes, depends on the operating system. That means depends on the bits. 16-bit operating system occupies 2 bytes of memory. So the next location address is 1002, 1004, 1006 and 1008. So in this way we can store data items in an array, as we all know that. So the address with the array name, here the array name is A, and stores the base address of that pointer in it. What is the base address? Base address is nothing but a first element of an array. So the first element of an array is the 0th index. So the base address, the address of 0th index is 1000. So A holds the base address, that is 1000. So the array name itself acts as a pointer. The array name is here A, which acts as a pointer. Why? Because it holds the base address. So we can consider here A acts as a pointer. We can say it is array acts as an internal pointer because It holds the first element address, that is base address. Consider the following example of an array declaration, that is int marks of 60. So here I consider array, that is array name is marks. The size of the array is 6. So for the above declaration, the compiler allocates 12 bytes of memory, because here I consider 2 bytes of memory. If it is a 16-bit operating system, the data type, the size of the integer data type is 2 bytes. So here I consider 2 bytes, then the size of array is 6 into 2. So total 12 bytes of memory is occupied by that array. And the address of the first memory location, that is address of first memory location is nothing but a 0th index. The first index, that is marks of 0, is stored in a constant pointer called marks. So here we have an example. Let us consider int marks of 60. So int marks 6, where marks is a array name. Array name is of marks, and the size of array is 6. We know that array index starts with 0 and ends with n-1, that is 6 minus 1, 5. So the elements, the data items stored in it are 89, 45, 58, 72, 90 and 93. These are the data items which I have given to that array. Let us consider the base address of this is 2000. In previous example, I considered 2 bytes that integer data type occupies. So the next is 2002, 2004, 2006, 2008, 2010. So here I declare a pointer variable called ptr. Now ptr is equal to marks. In previous example, when we consider a normal variable like int a, and let us suppose p, what does p do? P holds address of a, because here it is a normal variable. But here I have given ptr is equal to marks, where marks is not a normal variable, it is a array. As we have seen that array acts like a internal pointer. It is a constant pointer, means this, what does this marks name of the array occupies? This name of the array marks holds the first memory location address, that is the base address. Base address is here 2000. So this marks contains base address which is pointing to this array. So already it acts like an internal pointer, so that in this we no need to give like a address of marks, because marks is an array which is an internal pointer. It holds the base address. So ptr is equal to marks. Then I am trying to print this base address of marks. So here we printed the marks. So in this session we have seen about arithmetic. So pointer arithmetic and pointer to array. In the next session, we'll see the parameter passing techniques, that is call by value and call by reference. Thank you.